So here let us go to the introduction, that is combustion and flame. If you go for the introduction, if you are going for the introduction, here we can suppose, for example, your burning of candle is the first example. This is first example. Examples, if we take some examples I would like to give: burning of candles, then LPG gas, LPG gas for domestic cooking. Then we can take wood or charcoal burning. You can take then compressed gas, CNG in automobiles. Sometimes even if you take the food which we consume, taking the food which we consume, which we consume. So all these are different types of fuels. Burning of candle, here candle. So here in all these examples, here candle is a fuel. So this candle, actually it is a hydrocarbon, saturated hydrocarbon. Candle is a saturated hydrocarbon. Paraffin, we can call it as paraffin, which we call it as wax. Candle is nothing but wax is nothing but which contains saturated hydrocarbon, that is paraffin, that is wax. It can be acting as a fuel. Again, if we go for LPG means it's nothing but liquid petroleum gas. Also it is acting as a fuel. Then if you go for wood and charcoal, also these are solid fuels. I can say that these are solid fuels. Liquid petroleum gas is a gaseous fuel. Again, candle is a solid fuel. It is a solid fuel. Then again, CNG, compressed natural gas, CNG. If you take, this is compressed natural gas. This is gaseous fuel. It is gaseous fuel. Then food which we consume, food also it's nothing but it's a kind of energy in the form of fuel. You can consider the food also as a fuel for carrying the various metabolic activities. Food or fuel also. Fuel is energy fuel in the form of various metabolic activities we carry out, and this is it. So now what is happening here is, what we are able to understand here is, what we need to understand here is, that means every fuel, it has to subject, you take whatever is the type of the fuel, whether if the fuel is whatever is the fuel, you take fuel, you can take any kind of fuel, whether the fuel is candle or whether the fuel is LPG. So whatever may be the fuel, whether it is candle or liquid petroleum gas or wood or charcoal or CNG, that is compressed natural gas, or that is fuel, that is in the form of that is food, fuel, energy. Here the fuel in the form of food also it's a form of fuel. If you take food, for example, all these except the food, rest of all cases, if you take, all these needs a process called combustion. So what do you mean by combustion actually? How do you understand the term combustion? For example, if you take combustion is, suppose for example during Diwali crackers we take the magnesium ribbon we can take the sticks, I mean magnesium ribbon sticks, and we just try to ignite little amount of heat for that stick, and you can see that automatically it catches fire, and it gives this sparkling effect. And like different crackers, they glow with different colors. So all that, what is happening here is, in all those cases, what we are finding is we are just trying to give little amount of heat by passing small amount of oxygen. So what is happening here is, if you go for combustion, here the meaning of combustion is, that is, how do you put in proper meaning the word combustion? Combustion is simply nothing but heating a substance in the presence of heating a chemical substance in the presence of oxygen, to liberate heat and also produce light. For example, if you take, here if you burn the candle, for example, if you are taking candle, if you are burning the candle, if you burn a candle, if you want to burn it, you have to pass oxygen and you need to heat it. This word delta represents heat, this delta symbol represents heat. Then immediately you find that this candle gives, that is, light, and also it gives energy. That means it is subjected to combustion. Of course, candle is made up of a chemical substance, that is wax or paraffin. Similarly, if you go for liquid petroleum gas, yes, liquid petroleum gas contains hydrocarbons. It contains the hydrocarbons, saturated or unsaturated hydrocarbons. Again, these hydrocarbons, when they are subjected to oxygen, they produce the carbon dioxide plus water plus large amount of energy is released. Wood and charcoal, yes, wood and charcoal, both of them, they are a form of carbon. They forms of carbon. So take this carbon solid and you pass oxygen gas and you heat it. When you heat, you find that small amount of heat which we supply. If you supply small amount of heat, it gives carbon dioxide gas plus it gives excess amount of energy, heat in the form of energy, and also light. That means it has to be ignited to certain minimum temperature. Any chemical substance, if it wants to participate in the combustion, it has to be heated to a minimum temperature called ignition temperature. Once it reaches the minimum temperature called ignition temperature, that chemical substance reacts with oxygen and immediately it forms the necessary compound, maybe in the form of carbon dioxide or carbon dioxide and water, or any other substance any other new substance it may release, and along with that it also produces heat and sufficient amount of light. Same thing applies for compressed natural gas. And if you take food, we can consider the food as fuel, because we can consider the food as a biofuel for us. It's like food. Whatever the food we take in the form of energy, food in the form of energy in the form of fuel. We are trying to take food in the form of energy in the form of fuel. That means this food, when we consume, the food is the food which we take is always in the complex. It is present in the complex compounds form. These complex compounds or the elements or whatever which are present in the food, the carbohydrates, proteins, fats, whatever they are there in the food, these carbohydrates, proteins and fats, once they are consumed into our body it tries to break these complex compounds. That is, carbohydrates are broken down into simpler substances, proteins and amino acids also, they are broken down into simpler substances, and they are absorbed to the various parts of the body, and thus we get sufficient amount of energy, and with that energy we try to do the various metabolic activities in our daily life. So this is what you have to keep it in your mind when you take food as a fuel. So here, if you take the fuels as earlier what we have discussed here, fuels are of combustible fuels and non-combustible fuels. Combustible fuels are those fuels which supports the combustion. That means they allow the oxygen to pass through them, they chemically react with the oxygen, and they give light as well as energy. They produce large amount of heat as well as energy. So combustible fuels are those fuels which produce heat and light when reacts with the oxygen. And non-combustible fuels, if you take non-combustible fuels which do not do not produce heat or light, which do not produce heat or light when first of all it doesn't react with oxygen. Non-combustible fuels are those which does not react with oxygen. Even if it reacts with oxygen, there is no question of producing any kind of heat or light. So therefore we can simply say all non-combustible fuels are those substances or materials which do not produce either heat or light, or they never react with oxygen at all. So therefore we can just call them as non-combustible fuels. Now look at here, if you look at this table, we can easily differentiate which is combustible and non-combustible. For example, if wood is combustible fuel, then I can tick it as combustible. If it is non-combustible, that means if it is only combustible, just tick it as combustible and leave the non-combustible nature. Wood is combustible, so tick it as combustible material. Paper is combustible. Then iron nails, no, it is not combustible, it is non-combustible. Kerosene oil, yes, it is combustible. Then stone pieces, no, it is not combustible, so it should be non-combustible. Straw, yes, it is combustible. Charcoal, 100% combustible. Then if you go for matchstick, 100% it is combustible, very strongly combustible. Strongly combustible, I'll put 3 tick marks. Charcoal 2 tick marks, okay. Kerosene oil double tick mark. Wood also double tick mark, I'll take. Strongly combustible. Matchstick, yes, strongly combustible. No, that is glass is non-combustible. So here I can use the word that is strongly combustible. Strongly combustible, very strongly combustible, and here strong combustible. So by looking at this, it is very clear that wood is an ideal choice, matchstick is an ideal choice, charcoal is an ideal choice, kerosene oil is an ideal choice to carry out the process of, that is, combustion. Suppose for example, and one important point, one small experiment what we can do here is, if you take a flat board like this, wooden plank, take a wooden plank and take a candle. If this is the candle, you can see the candle flame is glowing like this. That means surrounding this candle, you're finding that surrounding this candle, you're finding that a medium is there operating. This medium is air. So air contains oxygen. So this oxygen supports the combustion of the candle and it tries to give the flame. But if this candle is stopped, if this candle, the next stage, if this candle which is kept on the wooden plank, which is having a flame, if I am going to place a tumbler like this, that means you are protecting the candle from participating in combustion. The air which is present in the candle is stopped. So gradually this flame, this flame is going to be put off, and you find some smoke comes out. This is smoke, and the combustion stops. So from this experiment, it is proved that combustion always requires sufficient amount of oxygen. This oxygen allows the flame, this oxygen allows the paraffin which is present in the wax to continuously burn, and with that burning it gives the flame, and with that flame we are able to understand that it is able to give the energy as well as light along with the flame. So this is how the process of combustion takes place. Here the combustion process without a tumbler, without an inverted glass, or else inverted glass we can take, and this is wooden plank. This is the melted wax we can take. This is the melted wax. So this is a small experiment we can show in the form of the combustion. And not only this, apart from this, you can also show the combustion in matchsticks. If you take a matchstick, this matchstick actually, if this is the wood, this is a small piece of wood where this matchstick is just, it is filled with some composition like this. this is the knob. This is knob of the matchstick. This I can take it as matchstick. This matchstick actually contains red phosphorus. The composition of the matchstick contains red phosphorus, then potassium chlorate, then it is also filled with little amount of antimony sulfide and powdered glass. So here this matchstick, you can see the knob of the matchstick. This is the knob. This is a small knob like thing. This is knob. This is a chemical knob. Actually that knob is filled with the different chemicals. It's just like a scotch mixture which is just prepared in the form of a paste, and it is just put on the support of this small wooden stick. And in this wooden stick right now we are finding that there is a red phosphorus. The symbol of phosphorus is P. It is filled with the powdered potassium chlorate. This KClO3 is called potassium chlorate. Potassium chlorate contains potassium chlorate, and you also have some amount of the compound which we call it as Sb2S3. This is Sb2S3, we call it as antimony sulfide. Antimony sulfide. The symbol of antimony is TBm. That is why the symbol of antimony is Sb. Sb means TBm, antimony. Antimony. The symbol Latin name is TBm. So the symbol is Sb. So the symbol is Sb. So what is happening here is, this is powdered glass. So when this powdered glass, when this whole mixture comes into contact with the rough surface, when it comes in contact with the rough surface, an ignition temperature is created with the rough surface. This knob generates the ignition temperature with that spark from the rough surface. Particularly the red phosphorus which is present in the scotch mixture of the knob of the matchstick, it suddenly acquires the ignition temperature, and immediately this red phosphorus immediately this red phosphorus gets converted to white phosphorus. This white phosphorus goes goes and it ignites the potassium chlorate. This potassium chlorate finally goes and it ignites the antimony sulfide, and therefore suddenly you find that the fire comes out. Suddenly it catches fire, and you can see that the flame comes out from the matchstick. This flame will give you the heat and also light in the form of energy. So this is how. So this is a case of proving. We're just trying to prove the combustion. In the case of matchstick. So this is how. That means we have taken two experiments to prove that how the combustion occurs chemically and how it supports combustion. So once again, wood is a supporter of combustion. Then kerosene oil is a supporter of combustion, good supporter of a combustion. Of course, paper also it's a good supporter of combustion, but kerosene oil is much more good supporter of combustion. Then charcoal is a good supporter of combustion. Matchsticks also, they are good supporters of combustion. Then what are the substances which are not the supporters of combustion? Means they are non-combustible substances. Not the supporters of combustion. Yes, glass is not the supporter of combustion, so it should be non-combustible substance. Then you can go for stone pieces. Yes, stone pieces are not the supporters of combustion, so it should be a non-combustible substance. Iron nails, of course, it is not a supporter of combustion, because if you want to melt the iron, generally these pieces of iron or iron nails, they are used in industries, heavy industries, in the manufacture of steel and different mega structures. This iron compound, the iron metal is used. If you want to melt the iron, or if you want to make this iron to participate in the combustion, you need large amount of energy. That the ignition temperature, above the ignition temperature, which is not less than 2000 to 2500 degrees centigrade, if you heat, then this iron melts and it becomes red hot liquid, and at that red hot liquid we can say that it has participated in the combustion, but that is beyond our handling. So it needs a special mechanism to adopt such kind of technique. So that's why overall we can say, under normal conditions, under low ignition temperature or below the ignition temperature, iron nail cannot participate in the combustion. That's why iron nail outright we can say that it is a non-combustible substance. Again, if you go for paper, it is combustible. Wood, it is combustible substance. So this table and these two experiments makes us to clearly understand what is the difference between the combustible substances and the non-combustible substances. So here the next part of the discussion is, that is combustible substances. Every combustible substance, characteristic features of combustible substances. Characteristics. So if you take combustible substances, the combustion fuels like, let me put it in this way, fuels like petrol, diesel, kerosene, cooking oil, of course wood, charcoal, whatever. If you take wood and charcoal, these are solid fuels, and of course petrol and cooking oil, all this comes under the liquid fuels. So whatever may be the case, every fuel, a fuel can be anything. The fuel can be a solid, it can be a solid fuel, it can be a liquid fuel, or it can be a gaseous fuel also. So every fuel, whether it is solid, liquid or gas, it depends on a temperature called ignition temperature. For example, if you take solid fuels like wood, charcoal, they require a very high ignition temperature. That's why they do not catch fire easily. Is my point of view. This is what we have to understand here. But if you go for, particularly if you go for liquid fuels, in particular, that is petrol, diesel, kerosene, they require very little amount of ignition temperature. They require low ignition temperature. Little amount of ignition temperature is sufficient. So there is a chance for them to catch fire easily. But however, if you maintain a constant temperature, for example, if you take small amount of, if you go to the rural area, because of the lack of the domestic cylinders supplied by the government, that is domestic cylinders contains liquid petroleum gas. Because of the lack of supply, the rural people even today in India, they depend on the cheapest liquid fuel, that is kerosene. So this kerosene, when it is maintained with a constant temperature of the constant ignition temperature, it cannot catch fire on its own. But however, intentionally, if you increase the ignition temperature on the kerosene oil, then automatically it may catch fire and there is a chance of explosion. But that never happens, because whatever the device in which we are trying to fill the kerosene oil, it is protected in such a way that it has a constant ignition temperature. With the help of that constant ignition temperature, it participates in combustion and it continuously burns. As it is burning, it gives the light as well as heat, and we try to consume it in the indirect form. Same thing applies for petrol and diesel also. The same thing is maintained. If that means petrol, diesel and kerosene, they have some fixed below ignition temperatures. That's why there is never such thing that they are going to explode by themselves. Until and unless you intentionally increase the ignition temperature for this liquid fuels, then there is a huge explosion taking place. When the explosion takes place, the damage is irreparable. That's why these fuels, I can say, though they have low ignition temperatures, they have high calorific value. They are highly calorific fuels, I can say. Calorific fuels. They are high energy calorific fuels. So for example, then if you take, that is if you are going for the cooking oil, and but even with the cooking oil also, we can take the same reason. If cooking oil, if it has constant ignition temperature, it can only boil, it keeps boiling but there is no such explosion. Boiling takes place. These are called constant boiling temperatures, constant boiling liquids, but you don't expect any explosion taking place on the cooking oil. Same thing here also, if you increase the ignition temperature, then there is a chance of explosion. Combustible substances, all the combustible substances, they have low ignition temperature, which have low ignition temperature. They are highly inflammable. Highly inflammable means they are dangerously explosive. So prevention has to be taken in such a way that they cannot explode under any circumstances. That's why if you see the petrol, particularly petrol, then diesel, then liquid petroleum gas, LPG, these are all stored in airtight containers. These are all stored in airtight containers, because when they come in contact with the oxygen, they directly or indirectly they participate in the combustion, and large amount of uncontrolled heat and energy in the form of light is emitted, and severe damage occurs. So because of this highly inflammable nature, suppose by chance if there is an explosion, that means if the fire explodes, these are called fire explosion. Suppose if there is a chance of fire explosion, then how to control the fire explosion? Fire explosion controlling activities. To control the fire explosion, we need fire extinguishers. To control the fire explosion, we need fire extinguishers. The commonly available fire extinguisher is, the first priority for the fire extinguisher is water. First is water, second is carbon dioxide, third, sometimes you can take even sodium bicarbonate, fourth, very rarely we are going to use carbon tetrachloride. We use water as a fire extinguisher because it immediately minimizes the ignition temperature, and it can douse the fire. Water can easily douse the fire, and it will not allow any further expansion. Carbon dioxide, yes, carbon dioxide is heavier than air. Carbon dioxide is heavier than air, so it sinks into the water. And prevents further combustion, because as long as the combustion is taking place which is not under control, that leads to the fire mishap, that automatically fire explosion takes place. So carbon dioxide is heavier than oxygen, that's why it can sink into the water and it will stop the fire mishap. This usage of carbon dioxide as a fire extinguisher is particularly we use in the seashores, because sometimes even the seas also they catch fire because of the oil spills. Once the oil spills are spread on the surface of the sea, then because of the high ignition temperature or because of the sudden temperature variations on the sea, sometimes the oil which is being explored in the sea, it catches fire. So they use this compressed carbon dioxide gas at high pressure, and they try to spray this carbon dioxide, or they send this liquid carbon dioxide into the water and they try to put off the flame. Yes, so sodium bicarbonate also, when it is used as a fire extinguisher, it can put off the fire. And carbon tetrachloride, this is very popular. It is stored in cans in indoor complexes. So all these are the different fire extinguishers which will be used for putting off the fire, or which can control the fire activities.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.